Okay, folks, my goal is to kind of give you an overview of each type of problem. I'm not going to do every problem with you, but don't have time for that. And you don't want to have a 40-minute video here. So, how do we determine whether these could be the side lengths of a triangle or not? Well, you take the two smaller ones and you add them up. So, like we take 9 plus 40. 9 plus 40 has to be bigger than 41. It has to be bigger than the largest side. So, obviously, 49 is definitely bigger than 41. So, check mark. It definitely makes a triangle. So, that's the yes part. Okay. Now, what kind of triangle does it make? Well, 94041 is the poster right above the whiteboard if you're sitting in class up and to the right. So that means that it's a Pythagorean triple. So 94041 is I'll call it a PT for Pythagorean triple. That means that it's definitely a right triangle. So we want this one right here. And they're showing us, like, if you were going to do work, 41 squared is equal to 40 squared plus 9 squared. Do you believe that? I mean, I suppose if you're in a rush, you're like, I don't care, Nelson, if I believe it or not. I just want the right answer. I want to move on. But if have Desmos open, you could definitely do that fairly quickly, right? You could go like 41 squared, right? And then you could go 40 squared plus 9 squared. And you can see that they're both equal to each other. So they're both equal to 1681. And that definitely shows you that it's a right triangle, because if the Pythagorean theorem works, then you have a right triangle. So check mark. If where the hypotenuse is too small, so let's write it like this: a squared plus b squared equals c squared. Definitely a right triangle if it works like that, right? If this piece, if c squared is too small, then we have an acute triangle. And I'll explain that in just a second. Let me put the word if here. If c squared, this is the only thing I consider, is where the hypotenuse is. Okay, if c squared is too big, then we have an obtuse triangle. Obtuse triangle, meaning the angle where the right angle would be is bigger than 90 degrees. Okay, dang it. If too big, I forgot the word too big. If too big, then we've got an obtuse triangle. Okay, so why does that work? Well, let's do like something that looks like 94041. So 94041 was perfect. Okay, let's say 41 got too big and it became like 43. Okay, so let's say it was 43. Well, now that 43 side is going to have to come down here, and this side here is going to have to swing out so that they can meet. And this right angle now is bigger than a right angle. It's become obtuse. Okay, so if it becomes 43, when you have 43 squared, I don't like where they have this on the left side where they're showing their work like that. I usually have my c squared on the other side. But you'd have 9 squared plus 40 squared is it equal to 43 squared? Well, no, it's not going to be equal. This side is 1681, and this side over here, 43 squared. Let's do 43 squared. Okay, so 43 squared is 1849. So we would have 1849 over here, and here's what you do. You'd circle this and say, nope, too big, therefore obtuse. And there's a fancy way of saying therefore in a little diagram. That means therefore obtuse. Okay. So you're going to do that with number 2. You're going to do that with number 3 and see if you can figure out, does it make a triangle first off? And then what type of triangle is it? Is it obtuse triangle, acute triangle, or right triangle? Maybe it's no. If it's no, you're in the clear because you don't have to do any other thinking. You just show that the two smaller sides do not add up to be bigger than the third side. So you're going to need Desmos with these because you got square roots in there, and you probably want some decimal approximations, except this one's really maybe a special situation. I don't know. We'll see. Anyways, so let's look at find the perimeter of this figure. Well, find the perimeter means you got to find all 4 sides, right? So we're missing this side. I'm going to call this side C. Why am I going to call it C? Because then I could drop an altitude in here like that and make a right triangle right here. Maybe I should put the right angle symbol on that side. This would be 8 long right here. I just cut off 4 from here, so this is 6 long over here, right? So there's 4 here and 6 over there. We care about the 6, 8, C triangle. So if I took that triangle out, it kind of looks like this, right? We got 6 here, we got 8 there, and we got C there. Why do we need C? Because we need to add C plus 10 plus 8 plus 4, add all 4 sides together, these 3, and then the one you're finding, and you've got the perimeter, okay? Oh, area, oh shoot, didn't see that part. Yep, area, we got to find the area too. In a trapezoid, the area is the bases added together, so 4 plus 10, you got to multiply it by the height. We know the height is 8, and then you take half of that. So we know the area without doing any work. You don't need side C to get the area. You just do that on Desmos, okay? That's how you do number 4. Going to this one, I want you to use Pythagorean Theorem. First thing you've got to do, though, is you got to figure out how big this side is right here. Now, they say the ratio is 16 to 9, meaning this is 16 and that's 9. Well, obviously, this is not 9, so we're going to have to set up a ratio that looks like this. So 16 to 9 is like length by width. So I got my length here and I got my width down there, right? And so I got to put the length here and the width down there, and then we're going to cross multiply. So I get 9x equals, you do 16 times 32 divided by 9. Once you get that, then you're going to do Pythagorean theorem with the L. So you're going to have L squared plus 32 squared equals C squared. You're going to have that C side right here, okay? The sides of a triangle are 2x, 8, and 12. Find the measure of the longest side, or the measure of the longest side is 2x. What is the value of x that makes a triangle acute? So when it says the measure of the longest side is 2x, that's the hypotenuse. So you're going to go 8 squared plus 12 squared equals 2x squared. Now, oops, I better put 2x in parentheses because 2x squared is going to become 4x squared. You're going to solve for x, okay? You're going to solve for x, and then what you're going to do is it says what value of x makes the triangle acute. So you want x to definitely be greater than 0. Oh, well, it's got to be bigger than 4, because if it's not bigger than 4, let me back up for a second. Hold on one second here. It's got to be bigger than 2, because when I stick 2 in for x, I would get 4. 4 plus 8 is 12. It's got to be bigger than 12. Otherwise, it's not going to make a triangle, right? And it says, what value of x makes the triangle acute? So it's got to be less than what the hypotenuse would be if you had 8 squared plus 12 squared. So when you solve for x down here, you're finding out what it needs to be a right triangle. So you're going to take this answer and it's going to go in right there. Okay. Now they're simplifying it down to something square root of 13. That's going to be a little tricky. Maybe we need a little bit more help in class on that one. Okay. So I think 7 is just a Pythagorean theorem problem. On number 8, another Pythagorean theorem problem. On number 9, Pythagorean theorem problem. Number 10 is, so I wanted to show you guys this a little bit. So if we made a little drawing here, all those points are in the first quadrant, right? So if I go out 3 and I go up 1, so let's say that's 3, and let's say this is 1 right here. Then I go over to 3 and I go up to 7. So here's where 7 would be, right? You could do this on GeoGebra if you wanted. And then if I went out to 11 and I went up 1, it says fill in the blanks, determine whether x, y, z can be the vertices of a triangle. Well, of course it can. We got 3 points. It's going to be a triangle. Okay, so that answer is definitely yes. And then it says, so yes, the measures would be, so how big is, first let's put some letters on there. X, Y, and then I think we did Z over here, right? So how big is this part right here? Well, 11 minus 3 is going to tell you that information. So you do that, 11 minus 3. And 7 minus 1 is going to tell you how big this side is over here. Then you got to do Pythagorean theorem over here. which the distance formula is kind of a funny thing. It feels like a different formula, but it's really just the Pythagorean theorem. So 11 minus 3 squared plus 7 minus 1 squared, that's just the Pythagorean theorem, right? So you're going to do that kind of work on this problem. And then you're going to do the same on number 11. I gave you a few of these, right, or a couple of them, okay? And then you're done. So I hope that's helpful. I'm not trying to give you all the information you need. I want you to still think a little bit about these problems. So good luck on the homework.